Good evening, dear student. Welcome to the YourPedia platform. Today, I'm just going to introduce some questions of a strength of material. Basically, जब I'm talking about the BHEL or HAL, so it will just contain the good questions for the strength of material part. Either you are just going for the other part, either just you are focusing to the thermodynamics, fluid mechanics, production part. These are the more theoretical portion. But when you are just talking about the strength of material part, it will contain the maximum number of the numerical portion. It has a it has a very less theory. So here you have to just take a approach of the numerical. So आपकी जो approach होनी चाहिए basically it is just belongs to the numerical portion. So here I am just talking about the some good question which will help you in the examination of a BHEL or HPCL. Okay, is this clear to you? Now here I am also discussing the some concept which is just based on this. So you are easily solve the question. And whenever I am just giving the question, I just give you the 20 to 30 seconds to solve this question. Try this question as soon as possible and just give the answer on the comment box. So so I can understand that you are understand about the what are the concept basic in this question. So today is a second lecture of the strength of material. We will take 5 to 6 lecture on the in case of a strength of material. Okay, good evening. So here I am just discuss the first question. Just see the first question and try to solve the question by yourself. Take a copy and a pen and try to solve this question and give the answer as soon as possible. So, student, this is the question. Okay, so here I'm just discussing about this. This question is basically asking so many examination. You have already seen this question so many times, either in the GATE, ESE or the PSU's examination. This question is very simple and some calculation are required to solve this. So here I'm just explaining the two methods to solve this question. First is FBD method. First is So first is FBD method. In this, what we are doing, basically we just draw the FBD of the different components. Here we are just see that P, Q, QR, and RS. There are three components. That is first one is this one, and second one is this, and the third is this. There are three components in this. So first of all, we are just draw the FBD. FBD of all three. We are just checking this is section PQ. This is section PQ. And another section is QR. And the last section is RS. This is RS section. Okay. So here you just draw the FBD of all three. Initially, how to draw the FBD? So in this case, you just see the forces. How many forces are acting on this member? So initially, you just see there is a one force is 50 kilonewton are acting on the left hand side. First of all, just take this one at the side P. That is 50 kilonewton. 50 kilonewton loads are acting on the PQ side. Now we want that our body is in equilibrium. So how the body is going to be in equilibrium? It is only in equilibrium if I am just applying the same amount of a force on the right hand side of the member. So we are also applying the right hand side 50 kilonewton. Okay. Now the member is going to be in equilibrium condition. So if I am just trying to, there is a no 50 kilonewton force are acting on the right hand side, but I am introducing by equalizing or by equilibrium into the this member PQ. So we have to just put the 50 kilonewton on the other side of the member. And there is a one another force that is known as a 80 kilonewton, which is are acting on the Q side. That is having the direction like this. That is having the direction like this, 80 kilonewton. Is this clear? So how the resultant came? So 50 kilonewton is the left hand side and 80 kilonewton is the right hand side. So the resultant is a 30 kilonewton towards the right hand side and having the nature like this. It is 30 kilonewton. Is this clear to you? Now, what will happen if this is in 30 kilonewton? So we also want that the member is in equilibrium condition. A member is to live in an equilibrium condition. So we have to just apply again 30 kilonewton forces on that side. So again, this 30 kilonewton is applied by me, but it's not existing. So for neutralizing this force on the right hand side, we have to just apply the another force 30 kilonewton like this. Is this clear? Now there is another force that is known as 20 kilonewton. It is just acting towards the left hand side. So we are again introducing a 20 kilonewton force in this side. Is this clear? So how the resultant look like? So 30 kilonewton is the right hand side and 20 kilonewton is the left hand side. So the net resultant came to be a 10 kilonewton towards the right hand side. So again 10 kilonewton is acting in the member in right hand side. Is this clear? Again, the net force are acting on the 10 kilonewton. You can check by this, by the whatever the force you are applying, whatever the FBD you are just drawing for the member, is this correct or not? You are checked by just see the other forces. So it is again 10 kilonewton here. So from this you can just see the number of forces are acting on the member. In the PQ member, it is a 50 kilonewton, which is having the nature of tensile. And in the QR, you will also just see the member is subjected to a 30 kilonewton. It is compressive in nature because it is just going to compress the QR member. And another one, RS member, the forces are acting on the 10 kilonewton is also compressive in nature. Is this clear? So the question is asking that a bar having the 100 mm square cross section area is subjected to an axial load as shown in figure. What is the value of stress in QR section? So it is just asking about the stress in the QR section. So stress in the QR section is sigma equals to P by A. So here you just see that P is having the 30 kilonewton, which is minus because it is subjected to the compressive load. After that, kilonewton, so you are just to multiply the 1000. After that, just you see the area. Area is 100 mm square. 100 mm square. Is this clear? So the values came to be a mm square. If I just want to convert into just 10 to the power minus 9. So just going to be, that is 30 mega Pascal, or the nature is compressive. minus 6. Okay. Is this clear? So the answer is 30 megapascal compressive. And we can also solve by using different method also. There is one other method as known as loading. We can just draw the loading diagram. Loading diagram, how it look like? We just draw the one axis that is known as a zero axis or the neutral axis, and above this force is showing to be a positive, and below this force is showing to be a negative. Is this clear? So if I am just see here, we are just taking the left and right section. So whatever the forces are on the left hand side, whatever the forces are left hand side is just take to be a positive. लेफ्ट हैंड साइड को क्या किया पॉजिटिव एंड राइट हैंड साइड को क्या किया नेगेटिव कर लिया. सो अब मैं क्या करूंगा, जस्ट मूव टू द 50 किलो न्यूटन अपवर्ड. दिस इज अ 50 किलो न्यूटन and another force of 80 kilonewton which is having the just opposite direction to the left one, so it is going to be towards downward, that is 80 kilonewton. 80 kilonewton. Okay, so 50 minus 80 just remain, this one is the 30 kilonewton. Okay, again we just see this 30 kilonewton remains in the same member like this. After that we are just drawing the 20 kilonewton again, which is 20 kilonewton like this. So this is 20 kilonewton and again 10 kilonewtons remains. So you can just see the forces on the member Q. PQ is 50 kilonewton and the QR is 30 kilonewton. That is in negative because it is showing the below the line, and the last one is a 10 kilonewton is on the last member. So you can just see this is also the negative. So you can also solve by using this method. Next question. Just try to solve this question. I will just give you the 10 to 20 seconds. Good evening. Good evening. Correct. Just try to solve this numerical also. Have you solved through? Have you solved this question? So before solving this question, I am just introducing what the value of a thermal stress in the case of a flexible supports. We are know about it that there are two types of a support. One is a flexible support and another one is a rigid support. So we maximum time we just solve the numerical by taking the rigid supports. In the rigid support, what will happen? It is alpha t is directly came to the numerical. Now I am just take the some concept which is just belongs to this. Here I am just taking the okay. Here just I am taking the flexible support. Here I am just talking about flexible support. What will happen in this case? We just discuss about this. So what will happen? There is a one bar. It is we are just going to be raising temperature, and what will happen if this is a flexible support? Generally, we are take the rigid support, but here I am just talking about the flexible support. So what is the meaning of flexible support? The meaning of flexible support is only that it will just allow some motion to transmit and some motion is going to be restricted. If there is some deformation came into the bar or the member, so some of the deformation is going to be allowed and some of the deformation is going to be restricted in the member. Is this clear? So I'm just talking about this one. If this bar is freely expanded, if let us assume there is no support at the fixed end, so if it is just going to be freely expanded, so what will happen? The bar is going to be extended like this, like this. This is a thermal expansion, delta th. If there is no restriction on the fixed end. Now I'm just talking about if I am just applied some flexible support at the end. If I'm just applying some flexible support at the end, what will happen in this case? There is some motion, some deformation is going to be restricted. Some deformation is going to be restricted because the one reaction came by the flexible support. Is this clear? And there is a some delta yielding which is just permitted or allowed by the support. Some delta is allowed by the support and there is some axial compression, this delta axial compression, which is just done by the flexible support. Is this clear? Is this clear? So from here we can just write delta th equals to lambda plus axial compression, which is just restricted by the supports. So what is the lambda? Lambda is known as the yielding of the supports, yielding of the supports, or gap between the rails, or gap between the rails. Whatever the support, whatever the yielding are provided by the support is denoted by the lambda. So from here we can just write axial compression equals to the delta th minus lambda. Okay, so as I know what delta compression is due to the R reaction, which is just support, which is just provided by the supports. So that is called PL by AE. So here the RL by AE equals to the delta TH minus lambda. So you can see here that R by A is known as a stress. Is known as a stress, and which is stress? It is thermal stress, because here we are just increasing the temperature. So we can just write sigma L by E equals to delta TH minus lambda. So from this, thermal stress is equals to the delta TH minus lambda into E by L. So this is the formula in which you are just providing the flexible support. Let us assume if there is no flexible support. Let us assume there is no flexible support. So what will happen is, there is no flexible support, so this lambda is going to be 0. This lambda is going to be 0. If the member is going to be expanded freely, so we are just writing delta th is equals to alpha t L. Is this clear? So we are just going to the numerical now. Now the formula is delta th minus delta th equals to alpha th equals to delta th minus lambda E by L. Just give me a minute, beta. So now we are just doing the numerical. Okay. So our numerical is saying that a 1 meter long rod is fixed at a one end. So it is just fixed by the one end. There is a rigid wall at a distance of 1 mm from the free end. There is a one wall. This is a wall which is 1 mm distance from the free end. है ना? As shown in the figure. What is the thermal stress generated in the rod if the temperature is increased by 100 degrees centigrade? So the temperature increased by 100 degrees centigrade, and E is equals to the 200 gigapascal, and alpha equals to the 12 into 10 to the power minus 6 degree centigrade. Is this clear? So I'm just writing this one. So just writing the formula. Sigma equals to the delta th minus lambda into E by L. So here lambda is given as a 1 mm. Lambda is given as a 1 mm. Now I have to just find out the thermal deformation. The deformation due to the thermal, that is alpha T L, whereas T is rise in temperature. So you can see here that is 12 into 10 to the power minus 6 alpha की value into temperature rise is increased by the temperature, that is 100 degrees centigrade. So it is also the 100, and L is the 1000 mm, that is equals to the 1000 mm. It is just came to be a 1000. So this is 10 to the power minus 10 to the power 5. This is just came to be a 1.2 mm. So the thermal deformation is came to be a 1.2 mm. So just I am just putting this thing in a formula. How many get the answer? How many of them get the answer? Okay, Akhil, good. So thermal stress is that is equals to the Alpha TL delta की value is 1.2 mm, and the deformation rate is lambda is equals to the 1 mm into E by L. What is the E? E is a 200 gigapascal. So we are just write 200 into 10 to the power 3. So now this is in megapascal. Now convert into the megapascal. What is the value of L? L is just again to be a 1000, because we are just write the term in the terms of mm, because this is mm, so we are just write the 1000 mm. Now the answer is, if I just see that is 0.2, this is cancelled to this, multiply by 200, और ये क्या है मेगा पास्कल. The answer is came to be a 40 mega Pascal. Is this clear? Is this clear to you, all of you? So the answer is 40 megapascal. Maximum students are giving the good correct answer. Okay. Just switch to the next numerical. Just try to solve this numerical. I will give you the 10 to 20 seconds. Try to solve this numerical. Monali clear. Yes. I think you are enjoying in this, because you will just learn some concept from this also. Anyone got the answer now? Okay. The question is saying that a bar of a 30 diameter is subjected to a pull of 60 kilonewton. The measure extension on the gauge length of 200 is 0.09, and change in the diameter is 0.0039 Find its Poisson's ratio. So I'm just talking about this one. Okay. So this is just saying that a bar which is subjected to a bar of 30 diameter is pulled by a 60 kilonewton force. Is pulled by 60 kilonewton force. Okay. Having the length is 200 and diameter is diameter is 30 Diameter is 30 D की वैल्यू कितनी रखी है? 30 Okay. So you can just see here there is a change in length is also given as, it is length of this 200 is 0.09 0.09 and change in diameter is equals to 0.0039 So first of all, we have to know about that what is the Poisson's ratio actually. So if I know just know about this, Poisson's ratio, this is known as a mu. Mu equals to the lateral strain upon longitudinal strain. lateral strain upon longitudinal strain. That is known as a Poisson's ratio. So if I am just know about the what do you mean by lateral strain, what do you mean by longitudinal strain? If I am know about strain is known as a change in deformation upon original length. Yeah, change in dimension upon original dimension. So here I'm just talking about the lateral strain and longitudinal strain. So first of all, we are know about what do you mean by a longitudinal strain or the lateral strain. So whenever we are just applying the force in which direction, the stress is known as a longitudinal strain. If I am just applying the force along this x direction, then this x is known as the longitudinal direction, and other two known as the lateral direction. If I am just applying the force along the y direction is known as a longitudinal direction, and other two known as a lateral direction. Similarly, if I am just applying the force along the z direction, then z is known as a longitudinal, and other two known as a lateral direction. Similarly, if you just see the forces apply along the length of the member, so the length of the member is known as a longitudinal strain, and whereas the diameter of the member is known as a lateral strain. Is this clear? So the mu is lateral strain, that is change in diameter upon original diameter. That is change in diameter upon original diameter. And longitudinal is along the length. So change in length upon original length, that is delta L upon. Okay, so here this is not talking about the sign. If I'm just see the sign here, so the length is going to be increased, so diameter is automatically going to be decreases. So the minus sign is came here, but I'm just taking the mod here, so there is no need to take the sign. Okay, so the change in diameter is equals to the change in diameter equals to 0.039. So this is 0.0039 upon diameter is equals to 30 mm. Upon longitudinal strain is change in length upon horizontal length. Change in length is 0.09 upon length is 200 mm. Is this clear? So if you are just solving this one, that is mu equals to 0.289. Just solve this one and you just get the answer. This. So the answer is C option. Okay, how many of them give the correct answer? Maximum students give the correct answer. Okay, good, good. So the next question. Take a 2 minute and take a 20 second and just try to solve this question. This is a good question. Anyone got the answer? Okay, so I'm trying to solve the question. The question is saying that a horizontal bar AB assumed to be a rigid, AB bar is assumed to be rigid, is supported by two wires CE and DF having the length L and 2L respectively and pinned at a point A. If each wire has a cross section area is A, the tensile stress sigma 1 and sigma 2 in the wire CE and DF are. Basically, it is just asking the what are the tensile stress, what are the stresses in the wire. What are the various stress in the wire? So for finding this, first of all, we are know about the what are the forces in the member EC and FD. So whatever the forces are induced in the member, we are just divide the area, we are just getting the answer. Simply, we are just can solve this like this. Someone giving the answer C, someone giving the answer A. Okay, okay. Just try to solve the question. So if let us assume if a member does not subjected any of the tension, so if this P is lying here like this, so there is a P1 is like here, and P2 are acting on like that, which is just supported the member and the support P. Is this clear to you? Same thing I can say that if this is P1 and P2 are having the deflection delta 1 and delta 2. If this P1 and P2 are not acting on the member, so the delta 1 are came to be a point and delta 2 are came to at that point. So this is a point E and F, and this is a point A. You can see this, है ना? And so this deformation is to be restrained by the P1 force and P2 force, or we can say this is to be restrained by the supports or the wire of the CE and DF. So if I am just going to find out the this deformation, so we can just calculate this one. So what are the deformation at that point? So as I know, this is a B and this is again B. If I am just taking this is a point M, this is a point N, this is a point O. Now just take a triangle. Take a triangle that is कौन कौन सा triangle? Triangle A, E, M and triangle A, F, N. We are just taking the two triangles. One is AEM and AFN, and both are the similar triangles. Both are the similar triangles. So we can just write from here AE by AF equals to EM by Fn. So AE having the dimension B and AF having a dimension 2B. And EM is representing the delta 1 and Fn is representing delta 2. So this B is cancelled to each other. From here we can just see this is delta 2 equals to 2 times of delta 1. The relation we are just getting here, it is delta 2 equals to 2 times of delta 1. So as we know, the deformation is depending upon the P1 L1 upon A1 E1. So here we can also write that is P1 L1 upon A1 E1 into 2 equals to P2 L2 A2 and E2. As I know, there is a same cross section area, same material, so this A and E are cancelled to each other. They are cancelled to each other, but having the length L, one wali ki length kitni L and second one is 2L. So we can just write here 2P L P1L equals to P2 into 2L. So from here we can just write P1 equals to P2. There is a one relation came into the terms of P1 and P2, but we have to take a relation in the P1, P2 and P. P1, P2 and P, because the answer given in the terms of P and this, not given in the terms of P1 and P2. So what we are doing? So we are just taking, now we just have to just get some relation between the P1, P2 and P. For that, we are just taking a moment at a point A. So just take the moment at A equals to 0. So here, first of all, just assume some assumptions. Assumption is that take one is clockwise and another one is anti-clockwise. If you're just taking clockwise as a positive, just assume anti-clockwise as a negative. So from here, you just see these are P1 force which are just applying on a point E, and this is applied on a F, and this is applied on a B. And we are just taking the moment at point A. So from here, we can just see that this is just going to rotate in an anti-clockwise direction. So this is minus P1 into B. And same thing, P2 is also going to rotate in an anti-clockwise direction, that is again minus P2 into 2B equals to, what will happen? This is just plus or equals to, we can just write P plus, and this is going to rotate in a clockwise direction, that is P into 3B equals to 0. As we know about P1 equals to P2, so we can just write it from here that यहाँ से अगर P1 equals to P2 लिखूंगा तो यहाँ से क्या आ जाएगा? P1 या 3BP equals to 3 times P into B. So we can see here that is P1 equals to P2 equals to P. So whatever the forces are acting on the at point E, F, and B, all are the equal. So the stresses are also the equal. So even if I'm going to find out the stress at that point, that is equals to the sigma equals to P by A. P by A. So here the force is P and the area is A. So either we are just finding at the point 1, this is 1, and similarly 2 पे भी same thing is P by A. So the answer is again D. Okay, are you got the concept here? How to solve this numerical? These are comes in so many examination. A type of numerical are came to so many examination. Okay, it's not to be neat. You just take the movement first and solve like this. You can solve any method. You can just solve first take a movement and do this like and do this like and take a movement. I am just approaching how the how you can just approach the question. But I don't know how much fees of this course, so just ask to the uh, executives. Okay, just solve the next numerical. Just solve this numerical. Just take a 20 seconds to solve this numerical. Option D. Okay. Okay, just I'm going to solve the numerical now. There are two approaches to solve the numerical. You can just see the member is going to be fixed by the support at the point A. There are two ways to solve this numerical. That is there is a first this is fixed by the. I am just telling the two method. One is a shortcut and another one is a some long, है ना? So ratio of the load shared by the parts AB and BC of the bar as shown in the figure. So as we know about the whole member is going to be fixed. So I know very well the total deformation is equals to the deformation at the first member plus deformation at the second member. So the member is going to be fixed by the fixed supports. What will happen? The delta 1 and plus delta 2 equals to 0. This is also known as the compatibility equation, which are just apply in the case of a statically undetermined member. So from here we can just write this delta 1 equals to minus delta 2. Let us, this is a member 1 and this is a member 2. This is a member 1 and this is a member 2. If P1 is applying on this member, P2 is applying on this member, so we can just write P1, L1, A1, E1 equals to P2, L2, A2 and E2. There is a one sign came to be here, that is negative. So we can write from here P1 into L1. What is the L1? L1 is the 2L by 3. A and E both are the same, so we can just write A and E having the same material and having the same cross section area. So another one is the P2 into, that is also the L by 3. So here also the A into E. So these A is cancelled to each other. From here we can just write P1 by P2 equals to the L by 3 upon 2L by 3. So if we just see L is cancelled to each other, 3 is 3. So the answer is P1 by P2 equals to 1 by 2. Are you got it? Some of the students give the answer B, but it is just asking the answer support in the AB and BC. So this AB is having the support P1 force and P2 it is just subjected by the second BC. So the answer is not 2:1. Is the answer is 1:2. Okay. Just solve this. C. Okay. Okay. This I'm going to solve this one. How the mode circle look like first of all? So if we just see here, this is a normal stressor lie on that axis, and the shear stress I lie on that axis. If I'm just going to draw the circle, like this is a mode circle. If I'm going to find out this is a sigma x, and this is a sigma y. Okay. If I'm just going to find out the radius of the mode circle, so that is equals to this one. The confusion is that some of these think the center of the mode circle and the center of the mode circle or the radius of the mode circle are both are the same thing, but it's not actually same. What will happen if I'm just find out this one? This is the radius of the circle, that is equals to sigma x minus sigma y divided by 2. But it is just asking the center of the mode circle. So what is the center of the mode circle? Center of the mode circle is equals to, what will happen, this sigma y plus this distance. So this is the center of the mode circle or not? So you can see from here that is sigma y plus sigma x minus sigma y divided by 2 is representing the center of the mode circle. If I am just going to be solved this one, so this is again 2 sigma y plus sigma x minus sigma y divided by 2. So the center of the mode circle is sigma x plus sigma y divided by 2. This is the center of the Mohr circle. So the answer is C. If this is asking the coordinate, there is a tau equals to 0 at that point. So sigma x plus sigma y divided by 2, comma 0. Is this clear to you now? Okay, let's switch to the next numerical. So here the equals to sign came like this, and this is also equals to, not minus, equals to. Let's solve this question. But the answer, okay. So this is talking about a foreign element in a pure shear. The principal stress will be given as maximum students sometimes take as 0. So that's why I'm just taking the question. Okay. If I'm just talking about the pure shear case, what will happen? A member is subjected to only a shear stress. It is subjected to only top. So what will happen? I'm just talking about the principal stresses. It is sigma 1 oblique 2 equals to sigma x plus sigma y divided by 2 plus minus sigma x minus sigma y divided by 2 का square plus tau xy का square. This is the value of a principal stresses. If I am just going to find out the principal stresses in any case. So in this case, we can see there is a no stress along the x direction. So sigma x equals to 0. There is a no stress along the y direction. So this is also equals to sigma y. But there is a only shear stress in the x and y direction. So we can see there is only shear stress are acting on that member. So from this formula we can write sigma 1 comma 2 equals to, this is 0 plus 0 plus minus 0 minus 0 divided by 2 plus tau square. So from here we can just write sigma 1 comma 2 equals to रूट के अंदर tau xy का square. So this is plus minus of tau xy. This is sigma 1 comma 2. It is clear? So the answer is first. Okay, just solve the next numerical. So this state is known as a pure shear state. What will happen in this case? So this is a pure shear stress case. So what will happen in this case? There is a no normal stress are acting on that member. So this is the answer. Maximum student give the correct answer. Some of them just centered origin. बिल्कुल सही. This is the case of a pure shear stress. How the more circle look like? This is like. This is the case of the pure shear stress. Clear? So in the previous case we just see ना कि sigma 1 equals to sigma 2 equals to tau आ रहा था. So same thing is you can just analyze from this. This is also tau. This is also tau. This is also tau. This is also tau. So how the circle are formed like this? The circle which is passing through the center of the axis. Clear? So we are just doing the next numerical. Just solve this one. What's the answer of that? What's the answer of this? See. So the question is saying that if a Mohr circle is drawn for a fluid element inside the fluid body at rest, it would be a circle not touching the origin, a circle touching the origin, a point on the normal stress axis, a point on the shear stress axis. So the answer is, let us see here. This is a fluid element. Let us assume this is a container which is subjected to a fluid. If I am just considering one element, fluid element, if I am just considering the one fluid element, what will happen in this case? If the fluid is in a rest condition, so there is a no shear force or no shear stress are acting on that member. If a fluid element is in a rest condition, so there is a no shear force. What do you mean by fluid? A fluid is a substance which is capable of flowing under the action of shear force. whenever the fluid is going to be flow, only when the shear force are going to be exist. If there is a no shear force are on the member, there is a no shear stress on the member of a fluid element, it means the fluid is in a rest condition. So the first thing is also clear here, that a member is to be in a rest condition. So what will happen? So there is a no shear force are acting on that member, force shear force is equals to 0. Similarly, tau is also equals to the 0. If their shear force is 0, then tau is also equals to 0. But when I am just talking about the fluid element, what will happen? A fluid element is surrounded by the fluid particles around it. So they are just always going to be compressed. So the equal forces are acting on the all side of the member, like this. Like this. So there is an equal force which will just create the equal stress, but in negative direction. So if I'm just going to draw a more circle for that, so this is just normal stress, this is the shear stress. So it is just a point on the negative side, of the axis. This is the point. More circle for fluid at rest condition. Is this clear? Okay. Just solve this one. Take a 20 seconds to solve this numerical. Have you got the answer? So as we know about, now just solve the numerical. Akhil, okay, good. So as we know about, it is just asking the maximum and minimum principal stress. So what is the formula for the principal stress? It is sigma 1 comma 2 equals to sigma x plus sigma y, yeah, sigma 1 by sigma 2 divided by 2 So this is the formula for principal stresses. Sigma 1 comma sigma 2 equals to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 का स्क्वायर प्लस tau square root के अंदर. So here we have a value of sigma 1 is 50 megapascal, sigma 2 is minus 100 megapascal, and sigma 1 2 this is a it is 40 megapascal. So we can just put this one. Sigma 1 is having the value of 50 plus it is minus 100 divided by 2 plus minus equals to sigma 1 is 50 minus 100 divided by 2 square plus tau xy, that is again 40 square. So from here you can just see this is again came to be a 50 minus 100, that is again 50. So divided by 2 is minus 25 plus minus. If you just solve this one, this is 40, this is just 50 plus 100 is 150, that is 75 ka square. So what is 75 ka square plus 40 ka square. So if you solve this one, this is just you are getting here minus 25 plus minus 85. This is just came to be a equals to the 85. If we just solve this one, this is came to be a 85. So what is the value of sigma 1 and sigma 2? So sigma 1 any maximum equals to 25 plus 85, that is came to a 60, and sigma 2 equals to minus 25 minus 85, that is came to be a minus 110 megapascal. So the answer is A. So just solve the next numerical. Just solve this one. Okay, can I solve now? So this is asking the question: a tensile stress is at a point across the two mutual perpendicular axes are 120 megapascal and 60 megapascal. The normal stress on a plane inclined at 30 degree to the axis of the minor plane. So I'm just talking about this is a one plane which is subjected to a 120 megapascal, and here also the 120 megapascal, and this is 60 megapascal. 60 megapascal. Okay, the normal stress on a plane inclined to the axis of the to at a 30 degree to the axis of the minor plane. Minor plane, that is this one. Any plane along the y direction is known as the minor plane. Plane along the x direction is known as the major plane. So I'm just talking about this one. So this is again this is a minor plane, and it is just subjected to a 30 degree. If I know the formula, that sigma n equals to sigma x plus sigma y by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sine 2 theta. So if there is a no sine component lie here, so this is just going to be 0. So what will happen here? What will happen at sigma x equals to 120 plus 60 divided by 2 plus 120 minus 60 divided by 2 into cos 2 theta. Cos theta मतलब cos 60 degree, cos 60, and cos 60 degree equals to the 1 by 2. Okay. So if you just find the normal stress, that is equals to the sigma 120 plus 60, 180, it is 90, plus this is again came to be a 60 divided by 2, it is 30 into 1 by 2. So this is came to be a 105. The sigma n equals to the 105 mega. Are you got the answer? Okay. Okay, thank you. Let's switch to the next numerical. Let's solve this one. Okay, just I'm going to solve the numerical now. So this is saying that if a cylindrical rod of a cross section A is applied with the uniaxial tension P, the maximum shear stress in the rod would be. So this is a rod. Is subjected to a P force like this, and having the area is A. Cross section area कितना है? A. Okay. So if I'm just see here, that is a sigma x having the value of that is P by A. If I'm just talking about the sigma y, there is a no stress along the y direction, so sigma y equals to the 0. If I'm just talking about a tau is also 0 because it is a uniaxial loading where a member is subjected to a tension. Okay. So I'm just find out that tau xy, tau equals to sigma x minus sigma y by 2 का square plus tau xy का square. This is not tau, this is only tau. So this is a maximum shear stress tau max. So tau max equals to sigma x की वैल्यू कितनी है? Sigma x equals to p by a. Yes, sigma x ही लिख लो. That is minus 0 divided by 2 का square plus again 0 root के अंदर. So this is came to be a sigma x square root के अंदर divided by 2. 2 का square. So from here you can just see here that is sigma x divided by 2, or that is equals to the p by a. So the 2 is also come. So the answer is p by 2a. That is the answer. B is correct. Is this clear to you? Okay. Just solve this one. Just solve that one. What's the answer of that? C. Okay, so the question is saying that more circle for the member stress in a thin walled spherical pressure vessel with a radius r and a wall thickness t under the internal pressure P will be. If I'm just know about the spherical case, so there is in the case of a spherical, what will happen in the case of spherical? In the case of a spherical, hoop stress equals to the longitudinal stress, circumferential stress equals to the PD by 4T. PD by 4T. If I'm just talking about here, that is a sigma 1 equals to the sigma 2 equals to the PD by 4T. Both is having the same dimension. If I'm just going to draw the more circle for that, or there is a no shear stress at that point, so it is just like a point on the normal axis, normal stress. Okay, so the option C is correct. Is this clear to all of you? Okay, good. Let's solve this one. So the question is that more circle for the state of stress defined by the this 220, 0, 0, 20 is a circle with क्या इसके center हो गया, what is the center and what is the radius of the more circle. If I see this, so we know about this, that is the center of the more circle. यहाँ पे सिग्मा x की वैल्यू कितनी है, that is 20 मेगा पास्कल, एंड सिग्मा y की वैल्यू कितनी है, that is 20 मेगा पास्कल, एंड द tau xy या tau yx equals to 0. This is just given by the this. If I am just going to draw this, this is a sigma xx tau xy, this is tau yx, and this is sigma yy. This is representing like this. So from here we can just see this sigma x is value is 20 megapascal, sigma y is having the value of 20 megapascal, and tau is equals to the 0. So if I'm just going to find out the center, so center is sigma x plus sigma y divided by 2. So what's the center of this? That is 20 plus 20 divided by 2. So it just came to be a 20. और the center coordinate is 20, 0. तो center coordinate कितने हो जाएंगे हमारे? Center coordinate is 20, 0. So one thing is clear here. So now I'm going to find out the what is the final radius of the motor circle. It is tau equals to sigma 1 या sigma x minus sigma y divided by 2 का स्क्वायर प्लस tau xy का स्क्वायर रूट के अंदर. So this is 20 minus 20 divided by 2 का स्क्वायर प्लस 0. So how the radius of the more circle or the shear stress, that is equals to the 0. So the option D is correct. Is this clear to you, all of you? Okay. So solve this one. Option A. Option A. Two of them only give the answer. Three of them give the answer. All of them the answer is A. So maximum student give the answer A. Am I correct? Okay. Someone give the answer B, but most of the student give the answer A. If I am just see the question, what is the question? Question is saying that a point in a structure member is subjected to a normal stress sigma s and sigma y along the two mutual perpendicular direction and shear stress in the xy plane. The orientation of the first plane theta p1 is expressed as, it is just asking about the orientation, and it is just asking about the theta value. It's just asking about the theta. So what is the value of theta? If I know about what is the value of theta, so or in the principal plane, it is just asking about the principal plane. So how the theta of the principal plane, as I know about, in the principal plane, a plane is said to be a principal plane when the shear stress is equals to the 0. When the shear stress is equals to the 0. As I know about the shear stress formula, that is sigma x minus sigma y divided by 2 sine 2 theta plus tau xy cos 2 theta. If this is equals to the 0 in a plane, so the plane is said to be a principal plane. So from here we can just find tan 2 theta equals to 2 tau xy upon sigma x minus sigma y. This is the tan theta. But it is just asking the orientation, and the orientation of the principal plane. It is just asking the theta. So the 2 theta equals to tan inverse of 2 tau xy upon sigma x minus sigma y. So the theta values came to be a 1 by 2 tan inverse 2 tau xy upon sigma x minus sigma y. Are you got it? So this is the value of theta. So the initially the some of the students give the wrong answer, but the answer is only B, not A. So because it is just asking about the orientation, not the value of a tan theta. It is just asking about the value of the theta. So remember this one. So just study the question carefully. Whenever you're just going to read the question, read it carefully, but it is going to be asked. You know very well that tan to theta value is a 2 tau xy upon sigma x upon sigma y, but it is just asking the orientation. It is just asking the theta value, not the tan to theta value. Okay. Just solve this one. So it is just asking the question, the state of stress at a point is shown below. Theta represent the plane corresponding to the principal stresses at sigma 1 and sigma 2. The value of theta 1, theta 2 and sigma 1 and sigma 2. So if I'm just see this case, this is a case of a pure shear stress. This is a case of a pure shear stress. So what will happen in the case of pure shear stress? Pure shear stress case is just like that. If I just write in the formula, that is sigma 1 comma 2 equals to sigma x या sigma divide by 2 plus minus sigma x minus sigma divide by 2 का square plus tau xy का square. I am also doing same case in the previous question. If we are just see that this is a case of the pure shear stress, in the case of a pure shear stress, the tau sigma x sigma y is equals to 0. There is no normal stress are acting on that member, and the principal stress is equals to the sigma 1 comma 2 equals to the plus minus of tau. Plus minus of tau. Is this clear? Plus minus of tau. So if I am just talking about the angle, so that if I am just going to introduce the angle, tan 2 theta equals to 2 tau xy upon sigma x minus sigma y. So what is the value of this 2 tau sigma x की जगह, that is tau minus times of minus tau. So it is just came to be a 1. So it is just equals to the 45 degree, and I just draw the diagram like this. So this is subjected to a at 45 degree, and another one is a 135 degree. So the answer is C option. Is this clear to you? Is this clear to you? So just solve the next one. I think this is all of them know very well. Anyone having the doubt? B, A. So point of contra fracture. So it is saying that contra flexor. So flexor is called a bending. Flexor is called a bending, or contra is known as a reverse. So whenever there is a change in sign, is known as a point of contra flexure. So whenever there is a bending moment are changing the sign, whenever the bending moment is changing the sign, it is known as a point of contraflexure. So it is not the point bending moment is going to maximum. It is the answer is bending moment is changes its sign. So always remember contra means the reverse of flexure means the bending. Whenever the bending moment is changing its nature, whenever the bending moment is changing its nature, it is known as the point of contraflexure. Is this clear to you? Solve this question. Someone give the answer B, someone give the answer D. So I'm going to solve the question. The question is saying that a concentrated load of P acts on a simply supported beam of a span length L at a distance L by 3 from the left support. The bending moment at a point of the application of the load is given by. So this is saying that a simply supported beam having the hinge support at their one end and roller support at their another end is subjected to a load P, which is L by 3 from the left hand side and 2L by 3 from the right hand side. If the member is having a length L, so it is just same to be a L from the left hand side and L by 3 from the right hand side. So just find out the bending moment at a point of application of the load. And we have to just find out the bending moment at the point. If this is a point A, this is a point B, so this is a point C. So we have to find out the bending moment at a point C. So for this, first of all, we have to just draw the reactions. So there is a one reaction R came to be like this, R A V, and another reaction R came at that point like this, R A H, and there is a one reaction came at that point also, R. Okay, so we are know about that R A plus R B equals to P. RA plus RB equals to V. I'm just talking about the vertical action, not the horizontal action. There is a no force along the horizontal side, so the RAH equals to the 0. So after that, how do we solve this? Just take the moment about A point equals to the 0, or just assume the one sign convention. I'm just assuming the clockwise is positive and anti-clockwise is negative. Okay, so this P into L by 3, P into L by 3, P into L by 3, and this is going to be rotated in a clockwise direction, and minus R B into L equals to 0. So from here we can just find out the value of RB. RB equals to P by 3. RB equals to P by 3. If I know RA plus RB equals to P, so RB value is P by 3, so the RA came to be a P minus RA RB, that is equals to the P by 3. So the RA came to be a 2P by 3. Now you have a value of the reactions that R equals to the 2P by 3 and RB equals to the P by 3. So either you have taken the moment about the left hand side or the right hand side. Both are the same moment came at the point C. So the moment at C, if I am taking from the left hand side, that is the RAB equals to RA into X. Up to this point. So the RA having the value of 2P by 3 and X is the distance from the point A to the point C. X is the distance from point A to the point C. That is also equals to the L by 3. So the answer is 2PL by 9. Okay. So the answer is 2PL by 9. So the answer D is correct. Is this clear to you? Let's switch to the next numerical. Is this clear to you? Okay. What is the value of a when a shear force at a point is 0, the bending moment is maximum, minimum, 0, none of this. As I know about as I know about shear force equals to the change of bending moment by dx with respect to a distance. Similarly, I'm just talking about the load, intensity of load, that is equals to the df by dx. So here I'm just talking about this one. If shear force equals to 0, it means dm by dx equals to 0. It means the movement at that point is maximum. It means the movement, whenever the first derivative is equals to the 0, it means the movement is maximum at that point. So from here we can say that the shear force, bending moment is maximum at the point where the shear force equals to the 0. Let's solve this one. Which one is a confusing question, baby? Weber? This one. Okay, so maximum time just checking that type of a question, so you can just remove your confusion. Na? You can sort out your confusion now. Okay, just I'm just talking about this question also. I'm going to solve some of one of the student give the answer. 1, 2, 3 give the answer. Okay, a simply supported beam of length L carries a uniformly distributed load W per unit length. It will have the maximum bending moment at the midpoint of the beam. The value will be directly. It is just talking about the a simply supported beam. A simply supported beam subjected to a UDL. If I'm just talking about the UDL just look like this. Okay, this is a UDL, uniformly distributed load over the length of member, and this equals to the W per unit length. And this is, let us say this is a length L between the span. If I'm just want to, first of all, you have to just solve this one. How to solve the UDL? If I'm just want to know about what is the value of the load intensity of this UDL, so we have to just take the area of this UDL for knowing the load or the load intensity of the this. So that is area of this one is W into L, and this is acting at the, so you see here this is from a rectangular shape, and a rectangular shape is having the centroid at the L by 2, so it just look like this. we can draw like a member having the R. This is assume A point. This is assume a B point. So this is a R A, and this is R B, and let us assume this is the W L. We are just showing this uniformly distributed load by the this one. If this is acting at the center, because this is acting at the center, why this is acting at the center? Because this is acting at the centroid of the whole member. So what will happen? The RA and RB came to be a W L by 2, and it is again W L by 2 due to the symmetry, because it is acting at the center and divided into two equal parts at the there. Support you can also find out by taking the moment and the equality of forces. Is this clear? So the RA and RB equals to the WL by 2 and WL by 2. So I have to find out the maximum bending moment at the midpoint of the section. So I'm just writing the bending moment equation. So the bending moment equals to RA into, let us assume this is a section X. This is a section X. Okay. So RA into X. RA into X. This is having the nature like this, clockwise, and the UDL which I just present here, it is having a nature anti-clockwise. So minus load is W into, कन्वर्ट किस में करेंगे लोड में, लोड पर यूनिट है तो W into X into distance कहाँ लगेगा, X by 2. Is this clear? So this is came to be a RA की value is WL by 2 into X is equals to the L by 2 minus W X equals to the W by 2 into L by 2 का whole square, because we are just asking the at the center of this. So it just came to be a WL square by 4 minus WL square by 4 into 2, that is 8. So this is equals to the again WL square by 8. Is this clear? So the maximum bending moment is WL square by 8. Okay. Any confusion? Just solve the next numerical. Solve this one. So someone answer, give the answer. C, A. Okay, just solve the numerical. A bending moment M and a torque T is applied to a solid circular shaft. If the maximum bending stress equals to the maximum shear stress developed in, then M is equals to, that is saying that कि जो maximum bending that is maximum bending stress, that is sigma B max equals to the sigma tau max. This is given as. Other things are remain same because both things are applied to the single bar. Okay. So I'm just talking about the bending equation. It is M upon I equals to sigma upon Y equals to E by R. So as I know, sigma equals to M Y by I, we can just write this M upon section modulus. It is Z. और Z equals to क्या हो जाएगा? I by y. I equals to, for a circular bar, it is equals to pi by 32 into d to the power 4 upon y equals to again d to the power d by 2. So this is came to be a sigma bending is came to be a 32 m upon pi dq. Sigma bend is equals to the 32 upon pi dq. Now just I'm talking about the torsion equation. Torsion equation is T by J equals to tau by R equals to Z theta by L. So the tau equals to T into R by J. J is the polar moment of inertia. So we can also write like this, T by ZP, polar moment of section modulus. So from ZP is known as J by R. J is pi by 32 into d to the power 4 upon t by 2. So ZP is came to be a 16. ZP is came to be a pi by d cube by 16. So from here, tau is came to be a 16t by pi d cube. So this is equation number second. This is equation number 1. So just equate first equals to second. So 32m upon pi d cube equals to 16t upon pi d cube. This is cancelled to each other. So the m is equals to the t by 2. The answer is A. Okay, is this clear to you? Good. Someone answer the C. Why C? Why C? So in that type of question, what we'll think, we know everything. We know the bending equation very well. We know the torsion equation very well. Still, we are just make the mistake. You can see only one student give the answer, one or two students give the answer, two, three students only give the answer A. Otherwise, maximum of them give the answer C. So there is some confusion always like that. So try to solve the numerical because you have a time to solve the numerical. In that type of a question, if you are just doing a mistake, so you always get the negative marks, okay, which is not good because this question is not going to be wrong. Okay, just solve the next one. So we're just going to solve. One student give the answer. Okay, so it's just saying that a mass less beam has a loading pattern as shown in the figure. The beam is of a rectangle cross section with a width 30 mm and height 100 mm. The maximum bending moment occur at. The maximum bending moment occur at. It is just asking the location of the bending moment. It is just asking the location of the bending moment. So you just solve the beam simply. If I'm just drawing the beam, draw here. This is a R A. This is the R C. Okay, RA and RC, and this is a point B, which is having the 2 meter at 2000 mm, 2 meter from this end, and this is also having the 2 meter. If this is UDL, so UDL equals to क्या हो जाएगा? Force into distance. We are just taking the area of that. Area is 3000 Newton meter, and into the multiply by the meter is, that is 2 meter. So it is just also acting me like this. We just think this is a 6000 Newton meter. Sorry, Newton meter in Newton only, है ना? Force है. This is Newton. Okay, we are just converting into the force 6000 Newton, because we are just multiply the length, this force into the this distance. So this distance equals to 2000 mm. Mm is converted to the meter. It is 6000. Okay, so we are just take the force equals to 6000 Newton. Now we have to just find out the reactions first of all. So we know RA plus RB equals to, RC equals to 6000 Newton. Okay, just take the moment at point A. This is a point A, this is a point C, and this is a point B. Take the moment at A equals to 0. Okay, so just take the moment, and assuming this is clockwise, anti-clockwise direction always. If you just take this is clockwise is positive and anti-clockwise is take to be a negative. So 6000 into distance, it is just acting at a 1 meter, because it is always acting at the centroid of the rectangle. So that is also a 1 meter. So 6000 into 3 equals to RC into 4. RC into 4. If I'm just talking about 4, this is 1500. So RC came to be a 4500 Newton. If this is 45 Newton, then the RB came to be a RB not RC. This is RA is came to be a 1500 Newton. 1500 Newton. So this RA equals to 1500, and this RC equals to 4500. Now we have to find out the maximum bending moment. So the short approach is that we know about if at a point where the shear force equals to 0, the bending moment should be maximum. Where the shear force is 0, the bending moment is maximum. So we are trying to find out the value where the shear force equals to the 0. So just draw the shear force diagram. If I'm going to draw the shear force diagram of the member, this RA is equals to 1500 force, like this. This is 1500, and this is remains same because no force are applying up to the point B. It is just remains same up to the point B. After B there is a UDL. After B there is a UDL which is having a direction opposite to the RA. So this is just moving towards the like a straight line, and this straight line having the 4500. Okay, so if I'm just going to find out the value of the shear force, so the shear force equation just look like a from this, that is 1500 minus the 3000 force into x minus 2 meter. Why? Shear force equals to just this is the force 1500, and this is a line due to the UDL, and UDL having the value of 3000 Newton meter, and just multiply the distance. So this is starting from this point now. So this is 2 meter, and this is again 2 meter. So this is starting from this, and we are just taking the shear force from that point. So this is equals to 1500 minus 3000 x minus 2, and whenever the shear force equals to 0 at point, the bending moment equals to the maximum. So we just put this is equals to the 0. Okay, so from here we can see this 1500 divided by 3000 equals to x minus 2. So this is equals to the 0.5. So the x value equals to the 2.5 meter. So this is equals to the 2500 mm. Okay, so the option is this, because this is also asking from the left hand side, so directly I am just calculate from the left hand side, not taking the right hand side. Is this clear to you? Okay, good. Just solve this one. The movement diagram for a cantilever beam whose free end is subjected to a bending movement. I'm just talking about here a cantilever beam subjected to a movement like this. If it is subjected to a movement, there is any shear force or on that member, there is no shear force on that member. So the shear force diagram will look like this. If I'm just talking about the bending moment diagram, there is a bending moment M is here. There is a one resisting moment which is came to be a member in equilibrium. It is came to this. है ना? So the reaction is also came to be just opposite to the applied one. If I'm just draw the bending moment diagram, this is just look like a rectangle. This look like a rectangle. So the answer is B. So the answer is B. Is this clear to you? Okay. Someone give the answer A. Maximum of the answer give the B. Okay. Let's solve the next one. So I'm going to solve this question. If this is a bending, if this is a the given figure shows the shear force diagram for the beam ABCD. The bending moment of the portion BC of the beam is. If I'm just going to draw a diagram like this, so if I'm just see, if I'm just introducing a P force like this, P force like this, and P force like this, and this. It means we are just assumed to be a one overhanging beam where we can just see this P is like this and this. If I'm just going to draw the shear force diagram, which is just equal to the same. If this P is and having the constant magnitude and again P and 0 and then P. So if I'm just going to draw the bending moment diagram, so bending moment diagram is depending on the force into perpendicular distance. So this bending moment diagram is like this. P into x, P into x, and after when we are just reach the point B, this is A, B, C, D. If I'm just reach the point B, so there is a no force, so it is just going to be the constant like that, and again 0. If I just write the bending moment equation, you will find this is just we are just drawing the diagram, bending moment diagram like that. So from here you can just see this is a bending moment in the section BC is having the constant value which is non-zero. So it is a non-zero constant value. Okay, let's solve the next one. So if you just see the question, the shear force diagram of a loaded beam is shown in the figure. The maximum bending moment in the beam is. So it is just asking them what is the value of a maximum bending moment. As I know about the maximum bending moment at a point where the shear force equals to the zero, where the shear force equals to the zero. So just draw the diagram. As we know about, shear force equals to the dm by dx. So the dm equals to f dx, or this f dx is representing the area under the shear force diagram up to the point C, because it is a maximum point where the bending moment is going to be maximum. So I have just considered the area under curve shear force diagram. So I'm just talking about the जितना area मेरे shear force diagram के अंदर आ रहा है. So here just you just see the diagram, you just analyze. This is the area under AC. So in this it is just a trapezium, or we can say it just contain a one triangle and a one rectangle. It just contain a one triangle and one rectangle. So if you just see the height of this is a 14 kilonewton, and this is again a 2 kilonewton, and this is having the length of 2 meter. So we are just find out the bending moment under AC curve. So it equals to the area of triangle plus area of rectangle. So what is the area of triangle? Area of triangle is half base into height. Half base is 2 and height is 14 minus 2, that is plus area under the rectangle, that is 2 into 2. So it is just came to be at 12 plus 4. So it is came to be a 16 kilonewton meter. So it is the value of the maximum shear stress under the diagram. So the answer is this. If you want to find out, you can just also consider that one area. This is also giving the same value. This is also giving the same value of that. Okay. So the answer is A. You just do the last numerical. This is the last numerical. Just do this. So the question is saying that a cantilever OP is connected to another beam PQ with a pin joint as shown in the figure. A load of 10 kilonewton is applied at the midpoint of the PQ. The magnitude of the bending moment at the fixed end O. It is just asking about the magnitude of the bending moment at point O. So what will happen in this? It is just a combined at two beams. So if I'm just going to break the beam into the two members, one is PQ, and another one is a. So it can combine the two beams like this. One is a cantilever beam and another one is a simply supported beam. If it is just subjected to a load of 10 kilonewton at their center, so what is the value of reaction at P and Q? That is also equal to the 5 and 5, because this is lying at the center. If I just see if this 5 kilonewton is acting at the towards upward direction, so same amount of force are acting at the downward direction to balance this one. So you can see this 5 kilonewton are acting at that, which is a vertically downward direction. And this is us asking the question, find the bending moment at O, at fixed support. That is equal to the force into perpendicular distance, and perpendicular distance is 2 meter. So the 5 into 2. So the answer is 10 kilonewton meter. So the option C is correct. So, all right, dear student, we will meet tomorrow. Okay, thank you so much.